There is a number that can be represented by both of these expressions. The first expression is 5n minus 7. And the second expression is 3n plus 1. And this number is, both of these expressions represent this number. We don't know what the number is, so I've just called it a here, because we actually don't know what a is. But a can be thought of as being expressed as 5n minus 7 and also 3n minus 1. So what do we do? Well, if a equals a, because a is the same thing, then these two different expressions must equal one another. 5n minus 7 must also equal 3n plus 9. What do we do now? Well, in algebra, we always want all our n's on one side of the equal side and all our numbers on the other. So the first thing I would do here is try and get rid of my 3n that's on the right-hand side, take it away from the right-hand side by taking away 3n from the right-hand side of the equation. If I do that to the right-hand side of the equation, I of course have to do the same thing to the left-hand side of the equation. Okay, so what happens? Now let's do this step 1. So 3n minus 3n gives me 0. So I now have, on the right-hand side of the equation, equals 9. Because the 3n minus 3n has given me 0. Then I look at the left-hand side of the equation. I now have 5n minus 3n. Well, 5 minus 3 is 2, so 5n minus 3n is 2n. And I haven't done anything yet with the 7. I'll do that in the next step. So my next step would be to get the 7 onto the right-hand side of the equation, because I want all my n's on one side and all my numbers on the other. The way to do that would be to add 7 to the left-hand side of the equation. If I add 7 to the left-hand side, I must add 7 to the right-hand side. I then get that 7 minus 7 is the 0 that I'm looking for. So I've got 2n by itself on this the left-hand side of the equation. And 9 plus 7 equals 16. So 2 lots of n equals 16. What does one lot equal? Well, I divide both of my equations by 2 to give me what one lot of n is. N equals 8. Okay, so I've now solved my equations to tell me that n equals 8. If I'm right, I'll find out what this number that I didn't know was. The one I'm really trying to find out is a. If I'm right, it won't matter which of these two equations I put in n, I should get the same number for a. So let's do a little check. What happens if I put number 8 into the first equation? I would get 5 times n, which I know is 8, minus 7. 5 eighths are 40. 40 minus 7 equals 33. Okay, let's try in the second equation then. 3 times n, 3 times n, which I know is 8, plus 9. 3 eighths are 24. 24 plus 9 also equals 33. So the number that I was looking for, a, this number in my sequence that I didn't know what it was, is 33. So a equals 33. This was two numbers that were consecutive after one another. So what could these two numbers be? There were two consecutive numbers that when you added them together, they gave you 33. These two numbers would have had to be 16 and 17. Two numbers following each other, giving you 33. Okay? So that was how you would have done that question.